Learning Objective 1. Identify the components of good gravel. For a gravel road maintenance operator, MnDOT Spec 3138 is the essential rulebook that ensures the aggregate delivered to a job site will actually perform under the blade and traffic. According to MnDOT Spec 3138, good gravel is defined by a proper mix of coarse and fine particles for compaction and stability. Gradation, the recipe of the gravel, is verified using a sieve analysis. In the lab, material is poured through a series of screens with progressively smaller openings. Gradation is simply the measurement of what percentage of the total weight stays on top of each screen and what percentage falls through. Let's look at the average retained test results for Class 1 gravel. We start at the top of the stack to identify the largest rock in the mix. 3/4 of an inch sieve. You will notice that 100% of the material passes this sieve. This means every single piece of rock in a Class 1 surfacing mix must be smaller than 3/4 of an inch. 3/8 inch sieve. This is where we catch our first significant percentage of rock. In this test, 20% is retained. With 80% passing, we are well within the allowable range of 65 to 95%. This retained 20% of intermediate rock provides the structural key needed to lock the surface together. Next, we look at the number 4 sieve, which is the technical boundary for rock. Retained result: an additional 17.5% of the material is caught on this screen. Combined with the 3/8 inch rock above it, this completes the structural skeleton of the road. Passing result: 62.5% of the mix passes through the number 4 sieve. This falls right in the middle of the allowable 40 to 85% range. As we move down the stack, the holes get much smaller, catching the last of the rock particles and allowing the sand to pass. Number 10, sieve. We retain 15% here, with 47.5% passing. The retained material on the number 10 sieve is fine rock, the smallest of the gravel particles, while the passing material is our sand and fines, which fill the gaps between the rocks to provide stability. Number 40 sieve. We retain 20%, leaving 27.5% passing. These sand percentages are critical. If these numbers are too high, the road remains loose and unstable. The bottom of the stack tells us if the road will actually stay together. Number 200 sieve. This screen is extremely fine. In this test, 16% of the material is retained on the 200 screen. Minus 200 fines. The pan. The material that falls all the way into the bottom pan is the most important part of the recipe. Here, we have 11.5% passing the 200 sieve. This falls perfectly within the 8 to 15% allowable range. The goal: these invisible particles, smaller than 0.075 millimeters, provide the plastic binder, the glue that allows the road to form a crust and shed water. By looking at the notes, you can see this specific sample is in the mid-range of all sizes. With a plasticity index of 5 to 12, this mix has enough clay content, at least 3%, to bind the rock and sand together. When your gradation report has the correct percentages of retained rock and passing fines, you have the material needed to build a tight, maintainable surface that performs under traffic. This infographic is a great visual for helping operators understand exactly what goes into a high-quality Class 2 gravel mix. Let's quickly walk through these results. 1. The golden rule: 100% quarry rock. The most critical takeaway from the is right at the top. Class 2 must be 100% quarry rock. Unlike some other classes that might allow for screened pit run gravel, Class 2 requires crushed stone from a quarry. This is vital because quarry rock has angular, fractured faces. These jagged edges lock together under the weight of a roller or traffic, providing much higher stability and structural integrity than rounded river or pit stones. 2. Understanding the sieve waterfall. Think of the sieve stack as a filter system. We start with large openings and get progressively finer. 3/4 inch sieve, the top. Notice that 0% is retained. This means every single piece of rock in a Class 2 mix must be smaller than 3/4 of an inch. 3/8 of an inch to number 4, sieve, the backbone. This is your structural rock. Combined, nearly 48% of the weight is caught here. This is the meat of the gravel that carries the load. Number 10 to number 40 sieve. This is your fine rock and fine sand. It fills the voids between the larger rocks so they don't shift. 3. The binder, minus 200 sieve/pan. The final column shows the material passing through the 200 sieve, often called fines or dust. 10.5% retained in pan. In Class 2, having about 10% fines is the glue. Why it matters? If you have too little, under 5%, the road won't pack down and will washboard easily. If you have too much, over 16%, the road will turn to soup when it rains. Here are the pros and cons for an operator to consider when working with Class 2 gravel. Pros. Why we use Class 2. Superior internal lock. Because it is 100% crushed quarry stone, every particle has sharp, fractured faces. These jagged edges act like Velcro, locking together to create a stable crust that resists shifting. High load-bearing capacity. It is the heavyweight of surfacing. The angularity of the rock allows it to support heavy agricultural equipment and tandem trucks without rutting or shoving as easily as rounded stone. Consistent gradation. Because it's a manufactured product from a quarry, the mix is highly predictable. You aren't dealing with the hit or miss nature of a natural gravel pit. You get that ideal 10.5% binder, the fines in the pan, consistently across every load. Washboard resistance. Once compacted, the stones stay put. This reduces the floating effect where loose rocks vibrate into ridges, meaning the road stays smoother for longer between maintenance cycles. Cons. The operator's challenges. Abrasive on equipment. Those same sharp edges that lock the road together are tough on tires and cutting edges. It is significantly more aggressive on high wear parts than smoother natural materials. Difficult to reshape. Once Class 2 sets up and locks, it is very hard to cut into. An operator cleaning ditches and pulling material back onto the crown will find they need significantly more downward pressure or a scarifier to break the surface tension. Higher production and haul costs. Being 100% quarry rock means it must be blasted and crushed, which is an expensive process. If your county doesn't have a local quarry, the trucking costs to bring in this specific spec can eat up a budget quickly. Dust management. Because the fines are often crushed limestone or granite, they can be very light and prone to blowing away in dry weather. Without a dust suppressant, like calcium chloride, you can lose that critical 10% binder to the wind quite fast. Per the 2025 Minnesota Gravel Spec, Class 5 gravel is primarily designed as a base material. It is the foundation of your gravel road. Because it is built to be a base, its physical behavior is very different from the surfacing gravels, Class 1 or Class 2, you might be used to blading. 1. The primary goal, drainage. The most important characteristic of standard Class 5 is that it is drainable. Low fines. It has a much lower percentage of very fine material, passing the number 200 sieve compared to surfacing gravel. Water movement. This lack of glue allows water to move through the material and away from the road structure rather than trapping it. 2. The gradation recipe. Min.3138. When looking at the Class 5 gravel sieve results, the most immediate difference for an operator to notice is that it contains much larger top-size rock than the Class 1 and 2 surfacing mix we discussed earlier. Here is a brief walkthrough of the sieve test results for Class 5 gravel. 1. The top-size rock, base layer strength, 1.5-inch sieve. Notice that 0% is retained, meaning everything in the mix is smaller than 1.5 inches. 3/4-inch sieve. Class 5 retains 15% of its weight in rocks between 3/4 inch and 1.5 inch. This larger stone is what gives Class 5 its strength as a base material. 2. The mid-range gradation. 3/8 inch to number 10 sieves. These levels catch a combined 42.5% of the load. This variety of sizes is designed to fill the large gaps between those 1.5-inch rocks to create a dense, solid foundation. 3. The sand and fines. Number 40 to number 200. A significant portion, 36% of the mix, is made of finer sands and silts caught in these screens. Minus 200, pan. Only 6.5% of the material is pure dust or fines. This is lower than the approximately 10% found in surfacing mixes because a base layer needs to drain water effectively rather than lock into a waterproof crust. Because Class 5 has larger rocks, up to 1.5 inches, and fewer glue fines, 6.5%, it is built to support weight from underneath, not to provide the smooth, tight-locking driving surface that Class 1 and 2 provides. 3. Why Class 5 is hard to maintain as a surface. If you try to use standard Class 5 as a final driving surface, you will run into several problems because it lacks the modification for surfacing. The marbles effect, because there is only 3% to 10% fines compared to 8% to 15% in Class 1, there isn't enough glue to hold the rocks. The rock will stay loose and roll under tires. Rapid washboarding. Without plasticity, PI, the material cannot form a bond. Traffic will push the loose material into ripples or washboards almost immediately after you blade it. No crust. Standard Class 5 is not designed to shed water. It is designed to let it in. On a driving surface, this means it won't tighten up or form a waterproof crust. Summary for the operator. Class 5 is foundation material. It is cleaner, less dirt/clay, than surfacing gravel so that water can drain through it. Class 5 can be modified to become a surface gravel, while standard Class 5 is designed as a base material to be placed under the surface layer. The modified version is engineered to serve as the final driving surface for gravel roads. Why do we sometimes modify Class 5? Standard Class 5 is designed to be drainable. It has a low percentage of fines so that water can pass through it quickly and out to the ditches. However, if you use standard drainable Class 5 as a driving surface, it will fail. Washboarding. Without binder, the rocks will shift and create corrugations. Dust loss. Traffic will kick the loose sand and silt into the air, causing the road to ravel. Float. You will end up with loose rock on the edges of the road that never packs down. Primary modifications. Some Minnesota agencies modify Class 5 for surfacing. They apply the standards found in Spec 3138 2D. Increased fines. Number 200 Civ. Standard Class 5 allows for very low fines, often 3% to 10%. For surfacing, this is typically modified to a range of 6% to 13.5%. These extra fines fill the voids and create the mortar for the rock. Added plasticity, PI. Standard base material doesn't require a plasticity index. Modified Class 5 requires a PI of 5 to 12. This ensures the fines are sticky, clay-based, rather than just dusty, silt-based. Top size limit. Even though Class 5 allows up to 1 inch or 1.5-inch rock in some base applications, surfacing modification requires 100% of the material to pass the 3/4-inch sieve to ensure a smooth, gradable surface. As an operator, your takeaway for this section is that surface gravel, Class 1 and 2, is designed to lock and seal, while base gravel, Class 5, is designed to support and drain. Surface gravels use smaller rocks, under 3/4 of an inch, and a higher percentage of fines or clay binder to create a tight, waterproof crust that resists washboarding. In contrast, standard Class 5 base gravel has larger 1.5-inch stones and fewer fines, allowing water to pass through the foundation rather than trapping it. Attempting to blade standard Class 5 as a driving surface usually results in marbles and constant raveling because it lacks the glue to stay put. If you must use Class 5 for the top layer, ensure it is modified Class 5, which increases the binder and limits the rock size to 3/4 of an inch so it can be effectively shaped and compacted. Note: MnDOT changed their crushing requirements for Class 5 from 10% in 2018 to 25%. It is good practice to verify current MnDOT specs every year because they do change from time to time.